this before when it came to quadratics. Families is basically just your different types of equations that you can get and solving for each of them using whatever information you're given. I'll just get everyone to just take a second to listen to me. Okay, so we're finding rules. Now, you're going to be given the rule more often than not, unless you're given a graph in which you'll have to pick your rule. But really, we're only looking at two types of graphs. One with a point of inflection, which is just basically a turning point, but with a little cube on it. And then one is the one with three different intercepts, which I would fully expect you to know how to put those intercepts in. Okay, so finding rules. A cubic function has the rule of the form y equals ax minus 2 cubed plus 2. So I've got a point of inflection graph here, but I've been given the point of inflection, which is quite lucky. They've given me the point 310, which is on the graph, and I need to find a. So what do I need to do with my 310? Sub it in. Good. So I've got 10 is equal to a. My x coordinate is 3 minus 2 cubed plus 2. And then I'm just going to solve. So a, 3 minus 2 is 1. 1 cubed is 1. So I'm not going to write that in. Plus 2. Minusing 2 to the other side, I'm going to get 8 is equal to a. And never forget to rewrite your equation with your new value that you found. Nothing too complicated. Okay, our next one here has the rule of the form f of x is equal to ax cubed plus bx. And we're given 2 points and we have two unknowns, which means what are we going to be doing for this question? Simultaneous equations. Fantastic. So I'm going to set up my simultaneous equations. Then I'm going to do them like any other simultaneous equations. I'm just going to simplify these. So I've got 16 is equal to a plus b. That one's quite easy. And then 30 is equal to 8a. 2 cubed is 8 plus 2b. Okay, so what do I evidently need to do to a? Yes, I'm going to multiply this whole equation by 2. So I'm going to get 32 is equal to 2a plus 2b. So this should be super easy for you guys now, the amount of times we've done simultaneous equations. I'm going to do what to both equations? Subtract. So I'm going to take this one up here from the bottom one. So 32 minus 30, I'm going to get 2. 2a minus 8a, I'm going to get negative 6a. And then my 2b's are going to cancel out. Solving for a, I'm going to get negative a third. 2 divided by negative 6, negative a third. That's my a. So I've got a now. Now I'm going to substitute in my b. So finding my b, I'm going to pick my simple equation that I had at the beginning. So 16 is equal to a plus b. Subbing in my a, I've got 16 is equal to negative 1/3 plus b. So 16 plus 1/3 is equal to b. So b is going to be equal to 49 over 3. Standard simultaneous equations. The ones I really want to focus on is these two. So if you're given a graph, you're not going to be given the function that you're trying to find, because I would expect you to know it from the graph. So with my first wavy graph, what kind of form am I looking for? My factorized form. Fantastic. So I'm going to have something with 3 brackets. What are my x solutions? Negative 1 and 2. So if I've got a turning point at 2, fantastic. So I'm going to have x plus 1 and x minus 2, which is going to have a squared on the bracket because it's got a turning point there. Fantastic. Now, don't forget the a at the front because we never know what the dilation is. Now we need to substitute in my second point, which they've given me up here, that 3, 2. You're going to use that point to find a. There's never going to be unnecessary information given to you, so you know you're going to have to use that point somewhere. So if you've forgotten about the a, I'm hoping that that coordinate will trigger you to think there's another point that I need to find. So again, I'm going to substitute in 2 for y and 3 for x. So 3 plus 1 is 4, and then 3 minus 2 is 1, squared is just 1. So 2 is equal to 4a, so a is going to be equal to 1/2. And that's pretty much it for that one. My point of inflection graph. What form am I looking for? Turning point, but with a cube on it? Yeah. So never forget about the A. The A is always out the front. X minus h cubed plus k. Now, what value am I expecting A to be? Positive or negative when I solve for it? Negative. Fantastic. I can see it's negative. If you don't need to put that negative on the A. I'm just getting you to recognize that you are looking for a negative number, because if you don't get a negative number, you've probably gone wrong along the way. So I'm substituting in my point of inflection. Now, I will always label it for you. I'm never going to make you read it off the graph. I hate reading stuff off the graph because you can always get it wrong. But the textbook loves to do it. So our point of inflection is at -1 and 2. So substituting that in, I'm going to have x equals +1 cubed and then +2. I need to find A. I'm going to use this point down here, my +1 and -2. So -2 is equal to A, x equals 1 plus 1 cubed plus 2. So 1 plus 1 is 2, 2 cubed is 8. So I've got 8a plus 2. Bringing that +2 to the other side, I've got -4 is equal to 8a. Dividing by 8, I'm going to get -1/2 is equal to a.